Hey guys, Mr.Whited here, and I want to do a new video, and I'm probably going to have this one in two parts just because there's a lot of information, and I'm trying to get all the content to you before school officially ends, which is coming up very shortly. So let's get started. So I just wanted to kind of go over first the quiz that we did last week. So thank you for everybody that took the time to take that. It's on STEM Scopes. You can still go back and take it. One of the highest missed questions that I saw was this one, and it says the diagram shows three different waves all traveling at the same speed. And it's asking which one has the most energy and why. So you've got wave 2, wave 3, and wave 1. Well, we know that when something has high frequency, you can see them where they kind of get really close together. High frequency means the wavelengths are very short. That means they're traveling at a very fast speed. Those are going to have the highest energy. Now, amplitude, which is the height of the wave, does make a difference too as well. So for instance, wave 2 would have the least amount of energy because it has the lowest amplitude. Wave 3 would have higher energy than wave 2 because the amplitude does get a little higher, which does indicate higher energy. However, frequency, high frequency indicates the highest energy. So high energy is related to frequency and amplitude, but frequency tends to be the biggest factor when it comes to the highest energy, if that makes sense. Okay, so the highest energy is going to be this guy, which is going to have the very high frequency. Okay, hopefully that makes sense. If not, you can ask me some questions about it later through email. All right, let's move on. So we're going to talk about the behaviors of light waves. So hopefully we'll be able to answer some of these questions. Why is the sky blue? How are rainbows formed? Why are some leaves green and some other colors? And there's a lot of questions in there. And usually it takes us several weeks to get through all this. But with the digital learning, it's going to be a lot shorter. So just bear with me and shoot me some emails and questions if you have them. You know, I'm always available too to go online and do a conference if you would like. All right, so we know the electromagnetic spectrum. We looked at this last week. All right, it goes from longer wavelengths on the left to higher wavelengths or shorter wavelengths on the right, lower energy to higher energy. And then we've got this little band here in the middle, and we call that band our visible spectrum, the visible light. This is what we see as humans, right? We can see these colors: red, orange, yellow, green, blue, indigo, and violet. Those are the colors we can see, red being the lowest energy color, violet being the highest energy color. So from the sun, and I think I've mentioned this in class before, when you're actually in space, this you don't see all the colors of the spectrum. You only see white light. So the white light is all the colors combined. So that's important to understand. So when all those electromagnetic waves come in through from the sun and they're traveling through space at the speed of light, they are all combined. It's essentially just white light. Okay, there would not be any colors. Well, where do those colors come from then? Well, they come from particles in our atmosphere. So there's a little video I want you to watch, which I think will be helpful too as well. But in order to understand what's happening, you have to understand the properties of waves and their behaviors. And they're pretty consistent amongst light waves and sound waves. I'm going to focus mainly on light waves. And when I get to sound, I'm going to try to do sound next week before we end. And we'll talk a little bit more about how sound specifically behaves too as well. But it's very similar. It's just not as fast. Okay, so the first thing you have to know is scattering. And scattering is when light waves hit a rough or uneven surface. So here is an uneven surface, and you can see what's happening. So these are my light waves. They're little vector arrows, little arrows coming in. And you can see that they're kind of bouncing off in all kinds of different directions, going all over the place. You could do this if you have a laser light and you have some tin foil, take that tin foil, crunch it up, okay, unravel it so it has all these little uneven surfaces. You can put that tin foil maybe on the wall somewhere, tape it up, take your laser, your red light, or if you have a green one, and shine it at that tin foil, and you will see the scattering. You'll see how all those different lights, how all those different laser, or how the light kind of scatters all over the place because of that uneven surface. It's a pretty cool effect. I usually do it in class, but you can do it at home if you have the materials. All right, so at this point, I posted this video and it's going to be in the instructions on Canvas, but it's called Why is the Skies Blue? And it has to do with scattering. So if you got a minute, you could pause this, go back to Canvas, play this video, and then come on back and we'll continue on. Okay, the next one we need to look at is reflection. I think this one's a little more intuitive to what you're probably used to in, in your normal life. But reflection happens when light waves bounce off an object, and depending on the type of object, some objects are better reflecting than others, right? Mirrors are a very smooth surface. They tend to reflect light waves much better than, like, say, your carpet in your home, right? So that's important to understand too as well. But reflection is essentially light wave comes in and it bounces off that object and then bounces back at an angle. They call it an angle of reflection and or angle of incidence. And we normally do go over all that, but it's not required in standards. But it actually comes at a kind of a straight line. So it goes straight in and then comes straight out. Okay, the next one you need to know is called refraction, and you've seen this too as well. And for all you Pink Floyd fans here, here's our prism. This is actually the famous Dark Side of the Moon cover, but it's actually it works. This is a real thing where you can actually take a prism if you have them. Here's my white light, and look what happens when that prism comes in. It hits this material, and it separates into all the colors. So why does it separate? Well, the light wave bends. Well, why does it bend? Well, it bends because it's hitting a new type of material. So remember, light comes in from space, and there's not a lot of things that it hits. It just comes pretty straight in. I mean, there are some things, but for the most part, light comes, it just travels to us until it eventually hits something. Usually it's going to be the Earth. And when it gets into our atmosphere, it encounters what? Air molecules. It might encounter some water molecules, and then it might encounter the ground. It might encounter, our solids and things like that. And when that happens, light actually slows down. And when it slows down, it bends. Well, that does some funky stuff when it bends. We see those in different ways. Uh, but you can see the white light coming in here and then bending. And you can do this if you have a prism. Again, take a prism, take some sort of light that tends to be kind of neutral or has like a white, like a light bulb. A flashlight works really pretty good for it. Turn the lights out, shine it into that prism, and see if you can separate all the colors from that flashlight. And you'll see all the different colors of the rainbow. So this is why we get a rainbow, okay? So when light comes into our atmosphere, there are all kinds of little water molecules floating in the atmosphere pretty much all the time. Now, sometimes there's less than others. It's less humid, right? So there's less water molecules in the atmosphere. But those little water molecules act like little prisms. And that light comes in, it hits those prisms just right, and it refracts. It slows down, it bends, and it separates into all the different colors. This is why when it rains or right after it rains, there's a lot of water in the atmosphere. You see those rainbows, right? You'll be driving down the street, you'll see those rainbows out in the open, and that's because of refraction. The light is actually separating into all the colors. And you can see the light, right? It goes in order: red, orange, yellow, green, blue, indigo, and violet. Violet is the hardest one to see, but it is there. It tends to be one of the hardest ones for our human eyes to actually see, but it is one of the last ones on the spectrum. Now, refraction can do all kinds of crazy stuff, cause optical illusions. This is probably one of the easiest things you can do at home, and I would encourage you to do it. Take a glass, clear glass, right? Allow some of that water, put some water in there, put a pencil in there, and look at it. What's happening here? Right? You get this kind of funky optical illusion where light is refracting. And it has to do with light hitting the water. So when light hits the water, it's coming in and it's actually bending. And that bending is causing us to see the pencil bend. It's like we're looking at it, you're almost like it's magnifying it, but then it's kind of pushing it over a little bit. It's a very bizarre thing, but refraction causes many kinds of optical illusions. So here's a cat kind of looking into the water. So the cat sees the water, or the cat sees the fish here, but the fish is actually right here. The fish looks up and it does the same thing. It sees the fish, it sees the cat somewhere up here, but the cat's actually sitting here, right? So when light hits different objects, it can refract, it can slow down, it bends, and it can cause all kinds of funky things to happen with our eyes. So here's a little PhET simulation, and this is the last thing I'm going to ask you to do today. This is for Wednesday, or if you're starting early, all right? And I want you to look at playing this, right? You'll have to download the PowerPoint to do it, but you can go through here and kind of look at how light refracts, and you can change different materials. You can look at you can change the index refraction. You can do all kinds of different things. You can go back and look at prisms. So here's different prisms. So let's see what happens when I take a prism and I shine a laser light to it. You can kind of see what happens to light as it hits an object. Let me make that. Let me see if I can make this class. Let's see, index. Um, and I want you to play with it and see what you can do. See if you can actually get these colors to separate. Is it possible? Nope. So here's my white light, and look, there you go. Right, so I want you to play with these and see if you can get them, see what you can do with them. Okay, and that's it for today. Uh, watch those videos, go through this video. Tomorrow I will have a part 2, and you can either continue watching if you like, or you can go and wait till tomorrow, Thursday, and then you'll have a simple little, well, not simple, but you'll have a little performance task to do on USA Test Prep. I think I only gave you 4, but there's some questions and things like that. I want you to go on USA Test Prep and finish that up, and that's what I'll take a grade on, okay? I hope everybody has a great week. I'll see you in part 2.